into your calculator, we should be okay here. So the partial sum for geometric series. Remember, a series is just a sequence that's being added together. To find the partial sum, we're going to write in sigma notation and then use your calculator. And if you don't have a calculator, you're going to punch it into Desmos. Okay, so for this first example here, let's find the sum of the first 7 terms in this series. Okay. I know that ... means this is an infinite geometric series that goes on forever, but we can still find a partial sum. We can still find the sum of the first 7 terms. Hopefully we all notice the common ratio. This one's the 2's. Doubling and cutting in half should be easy for us to notice. We're just multiplying by -2 for each of these terms in the series. So when we write in sigma notation, always start with the lower limit of 1. Our upper limit is 7 because I'm asking you to find the sum of the first 7 terms. And then write your rule, 3 times -2 to the power of n minus 1. And that would get you whatever the sum of these first 7 terms are. So let's punch that in on Desmos. 1 up to 7. And you need to be really careful here if you're using Desmos, or even if you're using your TI-84 calculator, the one that you have with you. You need lots of parentheses for exponentials. So 3, another set of parentheses, -2 to the power of, another set of parentheses, n minus 1, close them, and we get a sum of 129. Okay, and you might look at that number and say, wait, that seems really low for adding 7 numbers that are being doubled together. Well, you got to keep in mind, the last term here is going to be positive, because if we continue this pattern, it's positive, negative, positive, negative. The next term would be positive. That's the 5th term. The next term would be negative, which is the 6th term. And then the final term is going to be positive, which is why this last number is a pretty big positive here, because you're adding probably the largest positive number on there. If we double, we're going to get 48, 96, so on and so forth, a large positive number at the end. Okay. Why don't you guys try and just practice? All you need to do for this example is just punch it into your calculator. Go ahead and evaluate the sum 1/3 to the power of n minus 1. Don't need to expand, just evaluate. So practice punching it into your calculator. You can pause if you need to for a sec, but go ahead and punch it in. If you did this correctly, you would have gotten 1.494. I think you needed to round there, or it might have been exact. Clearly my do not disturb did not work. Great. I think I need to do that on my phone too. That's right. We're all learning here. Okay. Let's try. I'm going to put two more examples up in a sec, and I'll let you work through them. You can just pause, work through these last 3 examples. I'll put the solutions up, and then we will be done. And the homework will be posted on Schoology. It'll be due on Friday, and I'll post the homework solutions Friday morning. Let me give you 3 more examples to work at down here. Let's do... Oops, sorry, let's write that without our commas. Okay. Let's do... Alrighty, when you got that written down, why don't you go ahead and pause the video, and then you can work these out on your own and come check the solutions in just a sec. Remember, you want to write them in sigma notation. I didn't give you any of these written in sigma notation, so you need to write the rule and then punch it into your calculator. Okay, so for this first one, lower limit of 1, upper limit of 8. Again, this was doubling, multiplying by a -2, so our rule should have been 12 times -2 to the power of n minus 1, which would have gotten you -1020. And the reason this was going to be such a large negative number is because the 8th term in this series would have been negative. If the last term is negative or the last term is positive, that's usually going to result in your answer. For the second one, hopefully you notice this was not geometric. This was an arithmetic series. The common difference was -0.3. So we're finishing up this unit, hopefully, or we will be by the end of this week. We need to remember all of these. You're going to be asked to evaluate any of these on the test coming up next week. So still from 1 to 18, and then write your rule. Write an arithmetic rule, which would be -0.3 times n, and then I'm just going to go back to find term 0, which would be adding 0.3, so plus 3.5. If you did this correctly, you would have gotten a sum of 11.7. Okay, and the last one, this is as hard as it will get here. Mainly because when you go to write your rule, we have a lower limit of 1, but we don't really know how many terms are in this series here. You could just fill in what's missing if you like. That might be easy for you guys. But hopefully you're able to write a rule starting at 6,400, noticing that our ratio is just dividing by 4, which is the same as multiplying by a 4th, to the power of n minus 1. But you could have also found the number of terms by writing just a geometric sequence rule. So a sub n equals, and we actually want to plug in the last term because we want to know how many terms, what term number is that in this series. So we want to plug in our 25 over 16. Okay, for some of you, it might be easier just to expand this out and see how many terms fall in the middle here. But if you want to just use a simple equation, we could do that. The equations we were writing before equals our first term, 6,400, times our ratio of 1/4 to the power of n minus 1, because we're solving for n. We want to know what term number is 25 over 16. And look, this is just an exponential equation which we spent a whole unit on in chapter 4, we get 1/4 to the power of n minus 1 equals, let's not try and multiply this whole thing out. Let's leave it as 25 over 16 over 6,400. Okay, it looks messy, but we are going to take the log base 1/4 of both sides. And once again, guys, if you don't want to do this calculation, just find how many terms come in between and you can count. The series won't be such a large series that you couldn't count the number of terms. But we get n minus 1 equals, let's find out what that log expression is. So under functions, we need to go to log. Actually, we want log base. And 0.25. We need a couple fractions here. 25 over 16 over 6,400 gets 6. Great. We know it's going to be a whole number. Because this series is going to be a whole number of terms, so we get n equals 7. When you add that over, you would have gotten the same thing if you just counted. So 3, this would have been 4, 5, 6. There was actually exactly 3 terms in between that we're missing here. So a total of 7 terms in this series, and when you punch that into your calculator, you would have gotten about, we needed to round here, 2,132.2. So on the homework, if you're rounding, I would just say round to the nearest 10th or nearest 100th place. 1 or 2 decimal places is good for me. And you can leave your answer like that. Okay, that's just about everything I wanted to get through for our notes. Your homework it's in your book. Page 659, numbers 19 through 43 odd. Skip numbers 29 and 31. This is also posted on Schoology, so you don't have to write that down. Okay, if I made a mistake in there or I went too fast or you guys have questions, remember Google Meet office hours are tomorrow on Thursday. I will post an update for you guys Thursday morning with a Google Meet code. Once you guys hop in there, hopefully it's not too crowded, but if it is, I'll just kind of mute you guys one by one, and if you have a question, you can type it into the chat bar, and then I'll unmute you, and I will answer that question for you while screen playing, just like I am right now, onto the Google Meet. And hopefully it'll be a question that everyone has. And the only thing I ask for that, guys, is that you keep the questions to either the lesson that we did, the homework problems, or the test review. That way we have something to work on, some framework to work with, and I can answer questions on my iPad by working them out. So specific questions are a whole lot better than more broad general questions. If it's a broad general question about what's on the test, next week I will have that update for you over the weekend, okay? All right, guys, thanks. I hope that went well, and I'll talk to you soon.